will be recorded, and I'm trying my best to upload and giving subtitle. But since giving subtitle is quite heavy task, so usually I'm just using some AI tools to help me write the subtitle. So sometimes it's not really accurate. So hopefully still you can still understand what the lectures. Okay. 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 I think we can go about the courses. So this is our textbook. I forgot to bring one. Let me bring next class. Okay. This is our textbook. It's quite thick. This is the 9th edition. I'm not sure if there's the newer one, but I don't think so. I think this is the newer one. The 10, the 10 I think not yet come out. I will take mostly the content from this book. Okay. I have other references as well. If you want to see the 8th edition, which is I think the same thing, the James Stewart. The additional story about calculus, which is just application of calculus in daily life and how they can build up our mindset on calculus or mathematics. And then the two, I believe, supplementary. I also taught this yesterday on the basic math class. Wolfram Alpha, okay, and the GeoGebra. I think there's a lot of similar platforms out there eventually, especially after the AI and other tools that is utilizing the AI. Wolfram Alpha is for computation, so you can ask anything. Have anyone checked Wolfram Alpha? Okay, good. Okay, you can check wolframalpha.com. It's free. Well, it has the in-app, not in-app purchase. It's like having a premium subscription, I think. I'm not sure how much, but you can check that out. Well, you can compare with ChatGPT if you want. But I think ChatGPT itself still not having any plugins unless you pay the subscription. If you pay the subscription, you can have this Wolfram Alpha plugin inside your ChatGPT. So ChatGPT, I think now it has many plugins, but for free user, I don't think they open the plugins yet. And then the GeoGebra for graphs. You can also check the Desmos. That's also for graphs. So you can make out graphs into this website. I think it's quite easy, not really difficult to use, but at least try it once, use it. What else? Yeah, I think if some software. I think there are others for graphing, okay, and I think you can use that also. Okay, that is the reference textbook and our evaluation. So quiz will be 25, midterm will be 20, teaching assistant. This will be 10%, which means this 10% will be graded by your TA. So either it is attendance to the TA class, or maybe the TA give you some tasks sometimes. Well, it depends on you actually, and it depends also on TA what kind of grade she will provide. It's she because it's female. And attendance and participation. Well, for today's class, I will not cover the attendance, but for next class, I think I will count the attendance and also the participation. So usually we are going to have some kind of like a post test. Not every class, but at least every week. If you join the participations, at least you get some grade, some score. Well, it's just a 10%, but it's 10% sometimes. At the end of the semester, will be very important if you are really concerned about your score. Good score is good, but for me, at least just fine, like okay, good, pass, that's still okay. I'm not encouraging you like do not get perfect score. Perfect score is good, but sometimes it doesn't reflect what you learn in the study. If you are graduating and you are entering industry, that will be different experience. Okay? Maybe they will look like, oh, you get a perfect score, blah blah blah, but they will ask like your experience, your skills that is much more relatable for that industry. I'm not saying, okay, you get bad grades, okay, that's okay. No, try to be good, but sometimes make like a perfect score is not necessary. Okay. But it's good if you have one perfect score. It's good, but it's not everything. Okay? It's not everything. Because I know some students from I think last year or maybe several years, they will be kind of students that they will try to achieve those perfect score in many ways. For me, it's like a habit, a culture that it doesn't reflect your learning, it doesn't reflect your study. And sometimes it's become like obsession. And I think it's not really good if you think like that. Like study, you need to balance your study with your life, okay? You need time to rest, to play, to have fun, right? And to study. Make your life in balance. Okay? Studying in like the first year, the second year, especially for some foreigners, some international students here, aside from the heavy subject in the program, you also need to adapt to the environment, right? So you have like a double workload. So you need to try balancing your life first. Okay? You get bad score, I think still okay, but try to do best later. Okay? If you get bad at the beginning, because in my opinion, curriculum like in mathematics curriculum, every region, every country, you have different curriculum, right? And you are coming in Taiwan and you need to adapt to the Taiwan's curriculum. And sometimes you need to do like hard work. Okay, so I hope you can adapt to the environment really well. And if you have any problem, you can talk to me. Any problem, local student, foreigners, you can talk to me. Okay, if you have any problems. I'm really concerning about psychological, your mental issues. Okay, I'm really concerned about that. Okay. Okay, and then final exam, 35. Okay, that's structure. So the quiz probably 3 or 4. So probably if this will be 4 quiz, maybe this is 24, and I can add 1 to here. Okay. Or if we want to make it like 5 quizzes, it's also okay. It depends on our progress. Okay. If you think that we need more quizzes, then I think it should be okay. The quiz doesn't have to be in class. It can be like a take home, so you can work on your own in your home, or maybe the quiz also like an online test. I can prepare that, and I need to prepare the platform. You can open notes for the take home test, so you can use your books, your notes, use everything you have, but please work individually. Okay? I know it when I say this, it must be some student that they will work on quizzes in groups. Well, maybe you get good score, but for your learning, you will get nothing. I mean that, because if you take the quiz individually, you learn something, that will be your preparation for your midterm and finals. Okay? Because if you get like, perhaps your score not really convincing, and you still need like, oh, maybe I need to learn here. And you get to the calculus 2, you get to the engineering of math, and you get to the other courses that requires mathematics, you will get confused, and it will it will stress you out. Okay? It will stress you out. Okay, and then what else do we have here? Okay, this is a little bit my suggestion how to learn mathematics or calculus in general. First is actually practice. Okay? Practice means that sometimes I will give you some problems and maybe like homework. Please try by yourself. Okay, please try out by yourself. Okay? Understand the concept and the mentality for mathematics, for calculus. Every time you learn math, do not memorize the formula blindly. Okay? Okay? Me personally, usually I also forget the formula. But I try to find how to find that formula, how to get the formula for this one, and try to build the concept like that. It will help your mind to stay in logic. Okay? Because mathematics, calculus, we learn about logic. Okay? We learn about logic and reasoning. Okay? And always ask questions. Ask questions to yourself. Can I do this? Can I do this? Okay? Use resources, any resources. You have internet now, fast, right? When I do my bachelor, I have internet, but not as fast as today's. And I think when I'm in high school or maybe junior high, no internet. Yeah, no internet. So go to read a book, go to the library, manually. But now you can do it in your phone, right? Your laptop. So find resources. There will be a lot of tutorials, both in English or in Chinese. There are a lot of tutorials. Just try out, and sometimes because in math, in calculus, if you see the problem, sometimes the problem has many solutions. Maybe my solution is not the best way. You can try your own, and I will appreciate that. Okay. Sometimes students who thought like different way of thinking, sometimes I give them bonus point. Okay. Oh, this is true. Okay, this is good. But it needs to be correct. Okay, it needs to be correct. If it is coming from somewhere, and why this happened is not logical. and also study in groups. If you prefer studying in groups, well, if not, then it's okay. This is just my suggestion. If you want to study in groups, you can study in groups. Because studying in groups, there will be one or two person that how come this way? Oh, and the other one will explain. And sometimes the other one will, why do you do this? And the other one will explain. So you explain each other. When you explain, you learn something. Actually, like me here, I'm teaching you. Actually, I also learned something because before I'm coming this, I relearn all the things that I need to teach, that I need to learn twice than you. So if you try to teach someone, it means that you will learn twice before you teach the other. Okay? So if you have that passion to talk and teach, try that one. But sometimes there's also another person who excel individually. It's by hear, learn, just like one time watch and then he can do everything. It's his maybe ability. Well, it's also okay. You can learn doing that. Okay, but with my suggestion, try study in groups. And then try to manage anxiety, like I mentioned before. Try to balance your life. Okay? And since we are calculus is heavy subject. It's 4 credits, by the way. If you don't remember, it's 4 credits, so it will really affecting your transcript if you really care about your transcript. So try to manage your anxiety as early as possible. Okay. And this is, I think, the most important for all of this is set your goals. It's okay if you just, I'm taking this course because it's required me to take this course, or maybe, oh, because the program needs me to take this English one, so I need to take, okay, that's fine. It's still a goal. But if you want to make more specific, like I need to study calculus because it will help me to understand more about this, and this, and maybe you have something in mind what you do in the future. Maybe you are, oh, I want to work as a data scientist, I want to work in semiconductor industry, blah, 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 blah. Fundamental courses like calculus, chemistry, or physics, they are all fundamentals. There is one, like a small workshop, we invite one speaker from industry, I forgot the name, Synergation, I think the industry. So the company makes devices for other brands. So they make mouse for Logitech, they make also laptops for, I forgot the brand, but they making the equipment. And so the clients are from other companies. It's in Taiwan, I think. And the speaker says that the fundamental course at the end of the day is important. Maybe you don't really appreciate now, but after you are spending time in the industry, you will see the importance. So I'm saying this right now to appreciate the fundamental course. Okay? And setting goals, everyone has different goals, that's okay. So set goals, the more specific, better. Okay? It's better. Okay? And what else do we have here? Okay, this is the topics we are going to cover. So we are going to start from functions and models, limits, derivatives, differentiation rules, application of differentiation, integrals, application of integrals, the technique of integration, the further application of integration. Okay. So calculus basically only two parts, derivatives and integral. Okay, only two parts, and we are going to see why we need to study calculus. Okay. We start by the function and models because this is, I think, the basic, the really basic. Because we need to understand how the process will be. So we need to, because why we need to learn about function and what is the functions, right? So let me cover that for you in a couple of minutes. Okay, let me go through here with some stickers. What is calculus? Any idea? Any idea? Have you learned calculus before? Maybe some part of it? In high school, right? Maybe some part, not really all calculus, right? Have you learned? Not yet? Some part, right? A little bit part? Okay. And what's your conclusion? What's your name? What's your name?
My name is Fabricio. I'm from Portland. Mostly I think it's a science that every engineer needs to. Mm-hmm. And as I haven't get into very deep into the calculus, what I know is that it is kind of difficult, but at the end they understand it. It's like something that will open the doors to any science.
Okay. Yeah. Okay. So it's the first basic fundamentals for science. Okay? It's like we how to understand like biology, chemistry, physics, and mathematics. So they are like this line. So we understand biology from the chemical reaction, right? Enzyme, blah, 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 our organs, they have different reactions. And we understand the reaction from chemistry. In chemistry, we understand the molecules. The molecules is a part of matter, and matter has a physical phenomenon in physics. And physics we can understand through equation from math as a language. So math is kind of language for all these sciences. That is math. But we are going to specify the math which is calculus. Because math is quite large, right? We have the geometry, we have the statistics, blah, 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 right? And we have calculus. Any other opinion? What is calculus? I'm going to the left side here. And maybe you will feel nervous. Not me, but I will go for you. You want to talk? Okay.
I mean, I don't know if I can define it exactly, but for applications, I've used it in high school for kinematics. Yeah, like velocity, acceleration, and distance, displacement. And then I've seen, well, I didn't do it for my big project for high school, but you can use integrals for, Ben. But I've seen people use integration for calculating like the volume or area of like an abnormal shape of objects.
Okay, so I got some keywords. So the keywords are calculating the area, and then you said the kinematics at the beginning, velocity, acceleration, and that is actually quite correct. Okay, quite correct. Okay. So if we want to define calculus, okay, we define. Let's say we try first from the kinematics, velocity. What is velocity? Like you take some time to jog, and then at a certain point, you try to increase your speed. What's changed? It's become faster, right? Okay. So let's say I will write here first. That calculus is actually it's related to change. Okay? Because if you think carefully, like try to see the area, like you calculate volume or area, you actually kind of try to calculate that is something that is you can see the numbers. That is also related to change, how it's changing. Okay. So it's let me write clearly. Let me check what time we have. Okay, so I think I can cover at least for around 1 hour. So study. I want to make it more simple. Study all sciences that related to change. Okay, and it revolves around two things. Okay, it revolves around two key problems. The first is the area problem. Two is what we call the tangent problem, which is related to kinematics later on. And how these two are interconnected. I hope my writing can be understandable, because I'm not really convincing in my own writing. Interconnected. Okay. Okay, the first thing I want to approach is this area problem. Okay. Well, let's see from here. Okay. I have triangle here inside the circle. I have a square inside the circle. Let's start from this triangle. Let's start from this triangle. Okay. So let's say we have a shape, the blue shape, that we can increase its size, which means we can increase the these 3 sides become 4. Okay. And then from 4 becomes 5, right? Okay. And from 5 it becomes 6. And what's happening if we increase maybe 100? You see that it will approaching the circle. Okay. It will approaching the circle, and up until here, for the 12, it's already touching the side of the circle, and it's getting closer and closer. Which means that if we take this A, okay, so let A be the area, the area inscribed in polygon of n sides. It can be any numbers. So as n, let me write here, like n, as n getting increases, let's say getting largely, okay, sufficient, it appears that an getting closer to circle. And we can say that the A in this definition, let me just introduce you now. Okay. But we are going to discuss more later. Okay. So this A, we can say, is the limit as n approaching infinity of the an. And later on, in Greeks, they found that from this approach, I mean from this polygons approach, not limit. Limit is, I think, 17th century around. Yeah, Newton, Leibniz, that time. But in Greeks, they find how to approach the circle from the polygons, and they found that, okay, as we know and as we also apply for our daily life, that circle has an area of pi r squared. Okay. Okay, now if we go take a look another problem. Here I have the random graph, okay? Let's say I name it the graph as y equal f of x, which we are going to see a lot in our course. And let's say we want to calculate this area, the green one. Okay. The same way we did with the polygon. Okay. So the polygon, we make the sides as much as we can, right? Now, this curve here, you can slice it. Okay. You can slice and try to make something out of that slice. Perhaps just a rectangle. Okay. So this is just to illustrate how we can calculate. Okay. We are going to discuss more later. Okay. This is just an intro. So let's say we are going to start taking the cut, okay, for every rectangle here. And let's say we have 4. Of course, if you can measure this, you can know the area. You can just, 1 plus 2 plus 3 plus 4, okay, we have the total area. Well, of course, you have left with some holes here, right? That is not included. So what you can do? Okay, slice more. Slice here, slice. And the same logic, we take that as our n, how many rectangles we have, and take that using something called limit. Okay, something called limit. I'm not yet describe what is limit, but it's a tools to make or to getting close to something. Okay? And we take that and we can approach the area of this under this curve. Okay? And that will be the area problem. Okay? Just an intro. Okay, so you can see that as n getting to infinity, the let me just write an is getting close to a. A is the real area under the curve. Okay. So let me check. A is area under f of x. Okay, that's the first one. Okay, so the area problem. Okay. We are going to discuss later on. Okay, going to talk in depth. But maybe for integral, maybe another 5 weeks. Okay, and then, okay, do you still want to take notes here? Okay. Actually, the real course not yet started. This is just an introduction part. Okay. But that's okay if you want to take notes. Okay. So this is the logic behind the area problem. Okay. And the second one is the tangent problem. Before we are describing what this is about, what is tangent? That is touching. Right? So imagine you have this curve, you have this line, and that one point here is called the tangent. Tangent means the touch. Is it Latin? What was in Latin? In Spanish? Is there words from other language? No? Or yes?
That's what we say in Spanish.
I mean, usually Spanish like derived from something, or is it from Latin? Right? Okay. So it means in translation to touch. Okay. So when you have a curve and touch on one point, we call that a tangent point. Okay. This we call the tangent line. Okay. And because it's a line, like a linear line, we know the degree, right? How steep it is, right? So we know the slope, that which we usually call gradient, slope, or just a tangent. Usually they are the same thing. Okay. Now, what can we do from this function that is this curve, the black curve, that we want to make something that is related to this L, that is red line. The idea is, so I have one point P here, and let's say we have some random point anywhere here. So let's say from this point, and let me just make maybe here. Let's say this is Q. Okay, it's already P, so there will be Q. So let's make this P and Q another line. That is, cut this curve, which usually we say the line that cuts the curve. Usually we say the secant line. So we say this is the secant. So this is the tangent. Okay, then let's play a little bit between this PQ. Okay. Since this is a tangent, I would like to move my Q anywhere along this curve. If I take the Q going closer to this point P, what will happen? The secant also move like this. Okay? You can imagine. And at some point, nearby this P, you can see that it is getting closer and closer, and the secant is going to be similar with this tangent. And that's how we get the derivative. The previous area problem is related to the integration. This tangent problem will be related to derivative. Okay. You can view more clear maybe here. Let me. So you see, we put Q from the last point here, and then it's getting closer, and then it's getting closer and closer. And imagine if it's getting close to P, it's going to be very similar. And especially since we are on some limited pixels, right? Sometimes you just draw the line, you are not really going to see like really one point, or maybe because maybe your pen or your digital pencils is not exactly on one point because of the limited pixels. But if you try the website, the GeoGebra, you will see in the real world what is exactly one point really is. So if you want to try to visualize through some graphing calculator, so you know that it is exactly 1 point. Okay. So then, do I have or I don't have? So then we can make let me just draw here. Or maybe let me draw on the left side here, okay? So or maybe the middle one. The middle one. Like we can draw a triangle out of this PQ. And this will be, let's say, if we take this as X and this as a number A, a constant. So this distance is X minus A. And this one will be f of X minus f of A. And we will have that the gradient is as our limit from Q getting close to P as this M PQ, which means this part here. This is MPQ is f of X minus f of A. divided x minus a. And let me just finish a little bit. So m is limit as x getting approaching to a of f of x minus f of a over x minus a. Okay, so this will be an introduction to the derivative concept. Okay? So we are going to see this a little bit more later. Okay? So this is just to show you that the area problem and the tangent problem is the two key points in calculus. Okay? And we are going to see at the some in between derivatives and integrations. There will be some fundamental theory how to connect these two together. Okay? And there will be very, I think, very substantial, especially if you are taking more and more courses that requires mathematics concept. Okay. So, okay, let's have a break for a while, and we are going to continue and opening a new chapter from the function. Okay, this is just an introduction. Okay, we're back again. Okay, early semester is still in a full spirit, good spirit. Maybe after midterm, it will be different. It will be different. Every year, it's like that. So, I'm already getting used to, and that's okay. And you feel because the class starts after lunch, and you eat too much carbohydrate, especially white rice. And it is really normal if you feel sleepy, because it's because your consumption white rice will make you sleepy. That's the fact. If you eat too much white rice, you will get too much sleepy. And maybe if it's too much, it means that it's too much polysaccharides that is quite difficult to digest and to break down, and it becomes fat. So yeah, and it makes you sleepy because you have a lot of energy that you are not really put effort into make something out of it, and that's why you are sleepy. And so that's normal. So if you are sleeping in my class and you want to sleep for a while, that's okay. That's okay. Because when I was still a student, sometimes I was like sleepy, and then okay. As long as you understand, then that's okay. That's okay. Right? Go to function. So what is a function? I think you heard a lot since I believe you learned function. Is it from elementary school? I forget. Or junior high? Junior high, right? Junior high. Junior high? Junior high, right? Okay. So what is the function? Okay. So I think I need to make it a little bit to the okay. Okay, so you can imagine function like a machine. You put something and it will come out in another thing. Like maybe cooking, because I'm thinking about how to cook. So you put ingredients, you put into the your pan, you fry. Maybe you're making fried rice. Okay, you get fried rice. Okay. So it's like a machine that, if I make it here, you put something and you get something out. Usually we say something in X, the terms. What is X? Variable. I mean, what is a variable here?
An input.
An input? Okay, let me write that for you. Okay, an input, and this is output. And since the machine has a name, usually we name it as the F. Okay. Then the output will be the F with inside x. We can say this is f of x. Okay? But why we usually write x? Have you asked yourself? Why not a? Why not b? Why x?
Just because.
It's related to the history, actually. It's related to the history of mathematics itself. It's related to the history from Latin and from the Arabs. So the Spanish, they translated mathematics works from, I think, from the Arabic world. And when they translate, they are somewhat need to understand the concept. So the Arabs say, this is actually, it's called the unknown. It's called the unknown. Or in Arabic, it's called the shay. It can be anything. That's why it's variable. It can be anything. Or we can say it's independent variable. It can be anything. But they don't have the word for that. So they are, okay, x. That's how it becomes x. Interesting, right? No? In case your teacher didn't teach you about that history. Because I look at the Google and I found the TED Talk, I think I'm not sure the university, but I think in the United States. And that's how I got the information. Not from class, from YouTube, yay. So we call this independent variable. And we call this dependent variable. Okay. And we can also make it as an arrow diagram. So you can say we have some set of D that consists maybe A, B, C, like that. And we have another set that we call E. And then we say f of A, f of B, f of C. Okay. And then let's say that the arrow is the function. Okay. So this is just a simple diagram that's showing, okay, this is to describe a function, and we could say that D, okay, the D is our domain and E is our range. So we can say that this is our domain and this is our range. Domain means something that is possible within that part. Okay? Like, let me give you an example. You are maybe losing some, accidentally lose your money. You need to go where? Go back? Or go to your parents? Or go to where? Go to at least police, right? And then you need to report, I have lost this, and they will file the documents and okay, we are going to look for that items and we are going to call you. And then this happened to me actually several years ago. Okay, but if you go to, let's say, somewhere that, and you push them, please find my wallet. No, it's not my job. Or you could say, no, it's not in my domain. It's not in my domain area. It's not my responsibility. It's not in my fields. You can say that. The domain is something that it's supposed to be happening, and this is your works, and it's supposed to be, okay, the possible ways on the A, B, C. Can F join? Can G join? H, K, because it's not in its domain. Okay. So this is the function. Okay. Okay. So the boring words are a function is the version seems to be like cut out here, where in my display is quite okay. So I need to set this right. Okay, I think this also need to be corrected here because I'm using the GoodNote 6, the trial version, and I think it's not really helpful compared with the previous version. Okay, so the boring words for the function is a rule that assigns each element of the independent variable x in a set B exactly one element. So one element, one element, one element. Okay. And it's called the f of x in a set of E. So this will be all the possible x. This is possible f of x. Okay, this is just illustration. I think the same what I'm telling you about before. So the machine getting input and you get output, the f of x. And basically, what f means, it's another cut out. Okay. So it means this f is like a tool. Something that you have that can process this x into something. It can be like a model, okay, like a model. And usually we define function with graphs, right? With graphs. And equations, okay, of course. Algebraic equations. Okay, and then let me put this to the side here. Go here, and we can also, let me make it a little bit bigger. Okay, maybe here. Oh, it's cut out. Okay. Okay, so we can see that what is the domain? The domain means that this range here. So if we define the function f in a curve, just a random curve, let's say that just like that, from this point to this point, then all this point that is translated perfectly into this curve. So it can be seen that all points from here is perfectly to that point, and it's okay, and then one by one. Okay. Then this is called the domain, this is called the range. Okay. Notice that if you take this point, okay, and you take this point, it has the same f, but we still call it a function. So it can be done like that. So if we are having this, and let me use numbers now, 3, 4, 5, just a random number, 8, 9, 11. So if this, but if I make this, it's still a function. Okay, it's still a function. But there will be a case where we need to check whether it's function or not. Okay. Okay. This also describing how this x equal 1 is getting f of 1 here, x equal 2, and f of 2 here. And you can see that, okay, we can describe the height. Okay, the height. Okay. Okay, very good. And I think this is just a review of your high school or junior high. So I'm just using a simple example here. Too easy? No? Too easy? Okay. Okay, let's go for another example. Okay. Let me move here. Okay. So let's learn about domain. Okay. And I have this as example. So let's say this is a function f. Okay. So of course this is perfectly has some good numbers. So you can assume and estimate when you have x equal 1, you have 1, 2, 3, right? And when you have maybe x equals maybe here, x equal 3, maybe this will be 3, okay, and something like that. So if I want to make f equal 1, as I mentioned before, so we could say that, okay, perhaps it's 3 when we estimate the graphs. And when we have x equal 5, 2, 3, 4, 5 is here. So it's going down. So it's touching the negative sides. And it's less than 1, and then just using estimate, and it's rated maybe 0.6 or 7. Maybe just take it 7. So minus 0.7 approximately. Let me use approximately like that. Okay, but the next question is, what is the domain of the function? And then maybe after the domain, what is the range? So we see that this is just a normal function, and as I mentioned before, if you have different x, you can have similar f, so it's okay. So it's a function. So we can say that every step here, nothing wrong. So we could say all points from 0 to what this 5, 6, 7, so 0 to 7, that is the domain for the function. So we could say domain or D, we could write like this, or we could write like this. Okay. And the fact that we are, I hope you know why I'm writing this, because we have this one also, right? We can write this one. Okay. If you write with this bracket, which means that the point here is not included. If you write with this more rigid bracket like this, we need to include this number. And since there's nothing wrong with our graph, then we need to include the number that is mentioning here. So we are going to include the number 0 and 7. So that's why we write this as our domain. Okay? And what about the range? The range, let me write. Range is, so the range will be the height, like where's the minimum point of the function? So here. So what's the maximum point there? So it's about 4, right? 2, 3, 4. So we could say that this will be included like that. Or we could say it starts from -2, y, and 4. That's for range. Okay. Okay, too easy. Okay, how about if we have a function that is, let's start from the simple one. Just taking that 2x minus 1. How about we start by sketching the curve? Can you do that? Still remember how to do it? Just to make sure. Okay. How to make the curve from the linear equation? What do you need to do first? Okay. What do you need to do first? What?
Plug in the x. You should plug in the x.
Plug in the x. Okay, good. And then you get, maybe you can try from 0, 1, 2, 3, 4, and then you get the f of x. Okay, that's also good. So what I want to build is try to see it from different perspectives. What you know from the linear equation is there will be something that is crossing the x and y, right? We call it intercept. Try to find that intercept. How to find the intercept? We make equaling to 0. So take x equals 0 and take the f of x equals 0. Okay? If you take f of x equals 0, means that we are going to find the x where the curve will cross. Okay? So x is half. So perhaps this half is here. Okay? And I'm pretty sure the graph will be like this. Okay? Why? Why not this? Okay, good. So it's a positive, the gradient, right? Okay, let me just write something out of here. For those of you who are taking the basic math, we are going to discuss more about that in that lecture, but this is just a review. Okay. So gradient positive, so it's going to be like that. So take another one, take this equal to 0, f of x is negative 1, so we take negative 1, maybe here. Okay. So we take here, and we can draw our line perfectly. Not perfect, but I think approximately okay, because it's not perfectly accurate, but you can see the proportion is quite okay. So you can say that this is our y to x minus 1, or f of x equal to x minus 1. Okay. And how about the domain? What the domain? All numbers, right? All numbers is okay, right? So how do we usually write? We can write all real numbers or yes, like that. Range also all real number, or we can write this is also denotes all real numbers. Okay. And for our calculus course, we are going to just focusing only real numbers. There are many numbers, and including the imaginary, but we are going to exclude imaginary for a while and focusing on the real one. Okay, let me continue. And I think just a little notes here that we can consider 4 different ways to represent a function. We can represent like equations like that, which means it's algebraically we have the explicit formula that we can sketch the graphs, and the graph itself we can describe as a visual. Okay. Numeric, you have a set of tables, so x 1, 2, 3, 4, and then f of x, blah 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 blah, blah, and you can design the graph, or just a variable, so just the words. Okay.
But I think the most useful one is the
The visuals and the algebraic, because these two will conclude everything. Okay.
okay. Just to make sure we are okay. Let me write f of x let me write two functions. So one is f, the other one is g. So what's the domain for f?
What's the domain for G?
Minus 2 to
Okay, good. How about the G?
Any number.
x is not equal to 0.
Yes. Okay, good.
Okay, good. But is it complete answer?
Minus.
Okay, the first one, I'm going to start from the first one. The first one, we have something inside the square root. It's not showing. Okay, let me write here. So if we take something inside the square root,
It cannot be negative, right? So it means that, can it be 0? Can, right? So we need to set up that inside the square root that it should be positive or greater or equal 0.
okay, let me write here that this is going to be, anything here should be greater than 0. Okay? And sometimes we have this something, I'm just using the
Dot to just describe. It can be anything, but it should be a variable. Can it be 0?
No.
No. Okay, so we need to write.
we can say that this could be not equal to 0, right?
Or the one that makes 0. Okay? So I think for the f, I think easy to look at. So the x plus 2 need to be greater than 0. Or greater equal. Equal.
Greater equal 0. Okay, so which means that domain for f will be x plus 2 greater equal 0, or x should be greater equal negative 2. Or you can write negative 2 until infinity, but not include infinity. And because infinity is not an exact number, it's just an abstract concept. Okay? I think it's simple. But how about g?
How about G?
Any number higher than 1.
Higher than 1? Can it be in between 0 and 1?
Yes.
Can it be?
Yeah, it's
Yes, right. Okay, try half. 1/4 minus half. It's a number, right? It's a number. So 0 and 1 in between it can be, right? But here's the idea. You keep taking this as your references. So everything you have inside the square root, you need to have greater or equal 0. Everything you have when you have 1 over something, then that something is not equal to 0. So just keep in mind.
So what we need is, we just need to solve this algebraically. So this is not equal 0, which means that if we can factor out, then x is not equal 0 and x is not equal 1. So this is the domain. Domain is, usually we write, if you want to write completely, usually with this type of curve, x, as x is not equal to 0 and x is not equal to 1. That's Usually, if you want to write,
beautifully in mathematics. Right? Using this. How to read this? This is the domain is all x as x is not 0 or not equal to 0 and x is not equal to 1. Okay. The same thing here. You can also write
with that curve. If you want to write completely,
usually before you close the curve, you can write x is real numbers. That's like more complex, but I think still the same.
So I don't really force you to write completely. It's still the same. Or for this one, you can also write from negative infinity to 0, and then also include from 0 to 1, and then also include from 1 to infinity.
In which sometimes when you deal with inequality, to make sure that this is correct, you can use line numbers.
You can use line numbers and try the numbers instead. Okay, so you can use the line numbers, and you can check. For example, we have A, we have B, and then you can check which one is positive. Like maybe it is positive, negative, positive. Which one do you want to have?
Okay.
We're going to have
I think some review later on about the domain and some practices, I think, with your TA. But let's try to move on from this. Okay. Because later I think I will have a little bit of tasks, not really tasks, but just to make sure that I know your ability. Okay, now the next question, okay, is after we deal with the functions, how to represent functions, domain.
what makes functions function? Okay? Or we say how to test a function. I think we need to make this. Okay, we call this test the vertical line test. Okay. Okay, remember, previously I said that we have this. Let me just use the colors. So everything green here, everything red there, okay? And let's say this is going to that one. And now let's say we have this condition.
Okay.
See the diagram, the arrow diagram.
So we have the top one, okay, 1 to 1. But the second one, it has branches, 2 arrows. Okay, and then the third and the fourth, it goes to one direction, 1 point, the red point. Okay. Is it a function? Okay. Okay. Not a function? Okay. Why is not a function?
Two variables.
Yes. So you need to have, for each variable, okay, you need to have assigned at least one function, right? So from this part, from the second one, you have branches to
2 functions. So it means if you graph this diagram, probably at some point okay, So at some point, maybe at this point A, you have two different curves. So it's like this.
Okay? And we don't want this, right? Because it's not a function. So basically, if we are drawing a line, this line, let's say x equal a, let's draw that. This is the simplest way to check if it is a function or not. So you draw a vertical line. If the line crosses more than one point, it means that it is not a function. Okay.
So this is what we call the vertical line test. Okay. So let me just go here. Let me take this about that. Okay.
So this is a function. Okay. You can draw the vertical line anywhere and it's still safe. We call this, okay, we have a function. But here, we take here, this one, we cross more than one. This is not a function. Maybe from this point, okay, it's still a function, but below, above this, okay, that is not a function. Okay.
Okay. Okay, still too easy. Okay, the next one, and I think maybe just two last part. Okay, let's start with okay, let's start with this type of function, which we call the piecewise defined function. Which means one function can be described by many equations. Not only two, maybe 3, 4, 5. And then they will have different intervals. They will have different intervals. And they will have different variation of these equations. It can be like, this can be, okay, we have linear equations, but then it changed to the quadratic functions. Okay. So first, can we draw this?
Yeah.
Right? We can draw this, right? I think it's still simple. The first thing we see is the interval. Okay? We get an idea that, okay, -1 will be important. Maybe this will be the changing point where the graph will be different graphs. Okay, 1 minus x, I think easy to draw. X squared, just a normal
quadratic functions. So perhaps maybe just showing you the graph directly. Okay. Okay. Now we have, this is the 1 minus x. This is the x squared. And it clearly shows that the -1 here is the point where the graph is changing. So from 1 minus x. So to sketch the graphs,
You can start with just graph 1 minus x as usual. Draw that and draw the x squared as usual. That way, and then you can erase later on and make sure you get the correct interval. And then check the interval. Okay? You get this white dot like this one. It means that the point here is not included in the function. as we mentioned in the function itself. If we get this full dot like this, it means that we include the number here. We include the points, okay? And this point will be important when we discuss later on limit. Okay, this is what we call discontinuity.
Because the function is not,
It's not continue, right? There's something missing here, right? Okay.
okay. Okay, another one that is, I think, also important is the absolute value. So what is absolute value? So absolute values usually we write with this line. Okay. So what's the meaning for absolute value?
So every x that we put here, we will remove the negative part, right? It will be a positive, okay? So if we put -1, it will be 1. If we put -2, it will be 2, okay? Then what's the implications? What's the implications? If you want to draw the graph, if we imagine like y equal x, that is just like line like that.
Okay, let me draw here, just to get you. So if we draw, for example, like this, let's say this is the y equal x. Okay. And the same thing we do for, if you draw here, and let's say this is our y equal -x, okay?
Because the absolute value will make everything positive, so the negative part on x will be positive. The negative part on -x will also be positive. So you can see that if we
Combine this together, we are going to make, let me put here. So we are going to have, okay, and the other one is, yeah. So this is absolute value of x. So we can write this absolute value of x as piecewise defined functions as well. It can be equal to x when x is greater or equal 0, or negative x if x is less 0.
well, you can interchange the equal. You can be greater 0, less equal 0, same thing. This is why we need to write not having any equal here, because in terms of interval, if we already include the 0 here, then we don't need to include 0 in another interval. Okay, I hope that's logical. Okay. Reason. Okay. You can do the same thing. You can do greater 0 and then less equal 0. That's for the same thing. Nothing wrong with that. But we usually by default write like this.
Okay, that's absolute value. Okay. Okay, I think we still have a little bit time. I think I can complete all. So okay, I will review again next class, but let me just finish off with this even and odd function. even and odd functions is basically, the definition are, for even, if functions satisfy f, we input minus x and it will get f of x. Okay? And the example is, we can imagine the quadratic functions is normal quadratic. Okay. Okay, that's better. Okay.
So this is the example. So we take the negative x, and it will get the same value as when we input x. Okay? And this we can see from the x squared, right? Okay, and most quadratic functions. The odd functions, however, when we input negative x, they will get the negative f of x. Okay.
So you could see
This kind of having a symmetry, right? Symmetrical, or you could say symmetry here, and this is symmetry to this line, or to this line also.
so odd is if f satisfy, when we input the negative x, this will get negative f of x. Okay.
The example, maybe x cubed. You just want to remember it x cubed, because if you think of cubic, you put -1, the result is -1, right? You put negative, it will have another negative as the outcome. Okay. So even function, odd function. Okay.
So how to determine whether the function is odd or even is basically you need to put negative x inside those functions. For example, if we take the 2x minus x squared, or maybe this is too difficult, x with power of 5 plus x, so this is f of x. We put negative x, and then we define all this. And if we could make this as this is, we can write negative of our x5 plus x, which means this is odd, right? This is odd function, okay? But sometimes,
If you plug in negative x, and the result is not odd or not even, and you can just conclude it's not even, it's not odd. It's okay.
okay. And to conclude my lecture is this graph here. That we can have an increasing function, and we can also see decreasing. So in one functions like this,
If this is getting higher and higher, we can say it's increasing. I think it's easy to see, right? And from this B to C, it's decreasing, and then later increasing again. And we can say through the interval, so A, B increasing, B, C decreasing, C, D is another increasing.
or you can write down
Some notes that it's called increasing function if the f x1 here is less than x2, of course, because it's increasing. Okay, whenever the x1 less than x2, okay, and f x1 is greater than f x2 if whenever x1 is less than x2. Then we call this decreasing, this is increasing. Okay. Later we are going to discuss more on this graph and sketching a graph, I think in chapter 4. in chapter 4.
Okay. As an introduction, I think that will be the end of our lectures. Okay.
I'm going to have some review on all of this, giving some contextual problems, and yeah, I think that is for today's class.
Okay. Any questions? Any questions?
You can find in the library. I think they have. Oh, this one? Yeah, I will upload later.
Okay.